Okay, are we on? We're on. All right. What you see before you is a quick rendition of the JoePipe technology using different colors of paper. So I cut them out and paste them up, and I'm hoping that I'll be able to be in the picture. Yeah, can you see me in the picture there? Am I in? Yeah. Can you see me in the video?
Yeah.
Can you see my face?
It's a little dark.
I'm not blocking this here though. Okay. Anyway, my name is Joshua Taylor. I'm bringing to you the JoePipe technology. This technology was first given to me by divine inspiration of the Holy Spirit back in the spring of 2004 while living on Vancouver Island in Port Alberni in the spring of 2004. That same summer, when I moved to Nanaimo, I actually came across the discovery of the JoePipe technology, and in the dream, the Lord showed me a pipe, a small pipe, like a half-inch or 5/8 pipe, and I saw a fire spinning inside the pipe, and that same summer it became a reality. 10 years later, I put in about 2,500 hours of testing. I have about 500 different YouTube videos up on this. I haven't really aired anything for at least a year and a half, and on my old channel. So the Project Goshen channel, this is a channel that I'll be using to bring to you the JoePipe technology as it stands today. And I think most of you know that America and the rest of the world has come to a place where we're going to go into hyperinflation. And I know when the Lord gave me this, I knew it was a very, very efficient heating system. And this is what I'd like to bring to you. For example, running on, if I'm using propane and as fuel, that my cost per hour to heat a home, that means all the hot water and the furnace heat, is about 25 cents an hour using propane that you would buy in a 20-pound bottle. So you're looking at about approximately 25 cents an hour. And the test done a year ago when I was up northern part of British Columbia on a Russian-German community, and I built the furnace out of 2.5-inch ceramic pipe that's 24 inches long, and I was able to run that furnace on 16 ounces of propane, actually about 14 ounces. In a blue bottle of propane, you only get about 14 ounces, and that ran for 2.5 hours. So, like the diameter of the JoePipe makes a difference. This here, I'm using an 1.5-inch JoePipe that fits into a 2-inch T, and so you have about 1.5 inches by 16 inches. That's a good length for a JoePipe. So you're looking at about, for a medium operation, we can actually turn this part of the pipe red hot, maybe 4 ounces per hour. So you're looking at blue bottle, 1 pound of propane will last you about 4 hours. And so I know it's been proven to be highly efficient, and this is the first time that I'm actually releasing this technology in a more detailed way. And a friend of mine in Edmonton, he recently used a JoePipe configuration like this, and he put it within a one of those oxygen bottles, those tall oxygen bottles, the big ones. He cut a hole and welded one of these in, and he was able to heat that up to 350 degrees at, say, 1,000 pounds pressure. And so the outside of the JoePipe here, with about 3 to 4 ounces per hour, and using fan air, you can actually, this whole pipe will turn just bright orange, very, very hot. It's the flame itself is a implosion reaction flame. It's not an expansion of energy. This actually is a compression of energy. That's what and then what an implosion reaction is. It's the outside. If you crank up your propane, the excess of your propane is going to develop a flame on the outside. But the best you know, when you have the end of the Joe pipe tune where there's no flame coming out, just exhaust, like no flame, no color, that's when it's tuned the best, and you got the greatest fuel to air and your greatest heat release. So anyway, my friend did this, and he, you know, able to heat up an oxygen bottle full of water, and it dropped the temperature of the Joe pipe from about 2,000 to about 1,000 degrees. So the exhaust temperature coming out of the end of the Joe pipe, heating, say, 10 gallons, was about 455 Celsius. That's what he measured it at. And this is kind of what I theorized over the many drawings that I made up over the past. The big thing is that, you know, I don't have the shop and the means all the time. You know, you don't have a permanent lab set up, and so I'm getting this out to you guys out there. So when the time comes when fuel goes up to $10 a gallon, and where, you know, you're going to see maybe a 30 to 40% increase overnight in fuel, that you can make your Joe pipe heating, hot water heating system and furnace, so where you can survive the this world super depression that we're going into. Okay, so this is basically a 2-inch T. In the 2-inch T, the air comes into the bottom. You could have another T on here where you're actually pouring in fan air. You need a variable control on your air, and you can use compressed air. Fan air works fine. Okay, and so your fan air comes into here. It's a variable control. You got, on this setup here, I'm using propane. You got your propane coming through a casting. This is your 2-inch nipple, and I've casted this 1/4-inch feed using a refractory cement inside the 2-inch nipple, 2x2 nipple, so that allows that to be fitted into here. So that ports the propane into the back part of the pipe. This yellow here, this is a swirl device or a choke made out of soapstone, and so the center part of your soapstone is 1/3 your overall diameter. So this is 3/8 of an inch. This would be 3/8, and this would be 3/8. You know, there's about 1/3 ratio. That's about what you want. And the air comes in here, and so your air is actually going to come around the outside of this roll device, you know, around here and around here. You can actually score it. And it's also going to come to the center. And I usually have this wrapped with 19 gauge stainless steel wire that acts like a pressure fit to put in your choke assembly or your swirl device. It allows the flame, allows you to control the position of the flame. So if I took the swirl device and put it up here, the flame would be up here, right? So it allows me greater control of the flame. As I'm saying, this is where your implosion reaction is here. It's actually developing implosion or generating, you know, a slight vacuum, and that's driving the heat source. And if you were to add excess air to this, this could cause the flame reaction, or what I call the level 3 flame, to compress into electrostatic flame, or I've seen it where it actually would flash into a plasma. The fire would flash into a plasma and shear off the pipe. And I've seen many different manifestations. Am I still running on there? I can't see. I should have turned the computer so I could actually watch. Yeah, am I still recording on there? You have to come up to see. You're not going to be in the picture. Yeah, what's the time on the bottom on here on the screen? What's the time on the bottom? Is it still recording? 8 minutes? 9 minutes? I just gotta check it here. Recording 9:34. Okay, we got about 4 to 5 minutes. Nice.
Can't see that one.
Anyway, for you out there that you know, have some garage expertise and you're able to weld black pipe and all that, you know, this is just black 2-inch pipe, steel pipe. You know, 1.5 inch pipe here. You got your 2 to 1.5 inch reducer. This could be 1.25 inch pipe too, don't matter. The more narrow or the hotter the flame. And you got your 2x2 fitting in there, which where the propane is casted in. So that's it. Now when you want to operate, you turn on the air. Always turn on the air first, then turn on the fuel. So it actually goes right through the pipe. It comes out the end. So you take your igniter and you light it. So you're going to get a ball of yellow. But as you cut back on the pressure and the volume of both the fuel and the air, this flame is going to start to settle back here, and it's going to be a very bright blue here, and it's going to create like a thermal plug. The fire acts like a seal, like a water seal or a flame seal, and that develops negative pressure. And so as it goes from out here to here, it creates negative pressure in the pipe, and it's pulled back, and it begins to oscillate at the resonant frequency of the pipe. So this is, let's say, it'll be within the top 10% of the best heating systems in the world, just using normal fuels. Normal fuels, you could use propane, natural gas. You could use water bubbling through alcohol. You could use a mix of, you can make a bubbler where you bubble air through water and gasoline, 3 parts water to 1 part gasoline to make like a wet gas effect. You can probably generate your fuel for 10 cents an hour for use, and that's that's generating all the hot water on demand that you can use in a family. So this here would produce an unlimited supply of hot water on demand. You haven't done the yield test yet, but you gotta like in an ordinary system that they use for hot water, your elements are very, very small. We're talking about 1.5 inches, about this long, or however long your boiler is going to be. So you got a lot of surface contact of your element or the Joe pipe to the water, and it actually transfers. It's able to pull the heat out of the pipe without affecting the operation of the level 3 flame on the inside. And that's what you want. And so you still have an incredible amount of heat. You still have 1,000 degrees of heat coming out of here, Fahrenheit. And so you can actually use this for a secondary heat exchanger system. For a furnace, you could use this for a secondary hot water system, or an air heat exchanger. You can use it for an oven, like an old-fashioned wood oven. Many, many different things that you could use it for. Or you can put this all together into a box where you would have your water plenum here, 8 by 8 by 24 inches, and you would have a radiator on top that your water's being heated here, and it's going into your radiator. Hot water goes into the top, cold water comes out to be reheated, and you probably can cut it back to about 2 ounces per hour, because once you get if you're using it for a hot water on demand system, for generating hot water for a portable heat system using a truck rat or something like that, and a fan assembly, it's not going to take that much. And something like that would heat 1,200 square feet up to about maybe 1,500 square feet in the wintertime. So there's lots that can be done, but the main thing is that when the everything goes out of sight, where fuel is going to be rationed, you have a system here that's going to be able to handle the increase of the fuel. You got a system here that's much more efficient than present furnace technology and hot water systems. This is very, very simple. And I don't know any more that I can explain on this. You can put this together in many different configurations. I would advise that you out there to make your standard Joe pipe first. And so on this here, I've actually had another T like this with here, so I'm actually putting the air in this way. I have a fan in the fan box, putting the air in, and I have another nipple and a stand. So you can actually have a stand and your T for your air induction that supplies the air into here, and your fuel coming out of there. And so what I want to do is just bring across the standard operation of the Joe pipe, operating at 25 cents an hour for fuel for using propane. This can be totally off grid. You could have a fan like a 12-volt marine fan that only pulls about maybe not very much, maybe just maybe a couple amps at most, but small little fan, right? 4-inch marine fan. That's what I used before I actually went to the big fan, and they work fine. You're just putting in 1 atmosphere of air in there, and that works fine. So you could have your own hot water heating system along with your furnace system. You could use the outside of the flame to make a large cooking area or a heat box for baking bread, and you're totally off grid. You're able to survive. The beauty about it, you could upgrade the Joe pipe and use it to make steam, or you could drive it, use it as to run it through gasoline or oil to generate your own fuel on demand. Okay, I'm going to cut it here. That's me, by the way. Still recording? I think I'm up past my limit here.